Welcome, everyone. Welcome to Straight Science. Straight Science is an evening seminar series put on by University of Alaska Fairbanks Northwest Campus in Nome, and also University of Alaska Sea Grant, University of Alaska Fairbanks, Alaska Sea Grant, also in Nome. And tonight you're in the home office. And both Alaska Sea Grant and Northwest Campus, we are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. So tonight, Rozy, I'm so glad you're here. We have Rozy Bathrick, who is a PhD candidate, University of Massachusetts in Amherst. And number one, she's coming to us at a 4-hour time difference. So it's already, I don't know, 10:30 at night or something like that. So well done. And number two, a bird talk. You know, this region, it's wintertime or supposed to be wintertime for us. And hearing a bird talk is going to make us think of summer and when the birds return en masse and some good times ahead of us. So we need this talk. I know I do. And we're so excited you're here, Rozy. And I know you are specifically studying migrations. And I know some of our shorebirds do these really, as we say, spectacular migrations. And can't wait to hear what the latest news is on this. So take us away.
All
Thank you
right.
so much, Rozy. We're glad you're here.
I'm delighted to be here. Thank you so much, Gay, and to everyone online. So good to see these names and faces. And yeah, thanks to Straight Science and the university for hosting me. My name's Rozy Bathrick. I live here in Western Massachusetts. I go to school at UMass Amherst. And I'm going to share a bit about my research, both on the Seward Peninsula and other spots around Alaska. And I want to preface this talk by acknowledging the many collaborators that I've had the pleasure of working with. I think everyone in Alaska knows it's impossible to work alone. And on my team, I'm lucky to have fantastic members of the Center Lab here in the academic home at UMass. And three wonderful co-advisors, Nathan Center, who advises our lab at UMass, Jim Johnson of US Fish and Wildlife, and Dan Ruthroff of USGS, all of whom I've just had such privilege of learning from and with in the field and beyond. So thank you to those three, and then also to the many, many volunteers and technicians and helpers I've gotten to work with in Alaska over the last 3 years. Can you hear me okay? I just heard some voice.
Yes, I'll see
Okay.
who's got their button off and silence them. But go ahead, you're doing great.
Okay. Thanks. Okay. Yeah, so I want to acknowledge just all the work I've gotten to enjoy of others. All right. So I want to start by just acknowledging that many, many people rely on birds and have relationships with birds. In Alaska, one of the incredible things about being up there is to actually witness migration. Um, and many, many people travel to Alaska to do so, go on birding trips. And there are many ways of connecting to birds, be that hunting, traditional harvest, be that bird watching, um, egg collection. And I'm so eager to hear stories of folks in this audience and other people in Alaska of ways that we all connect to birds. I think being in Alaska and being able to observe some part of migration is incredible. Um, and I just consider myself so lucky to get to make the migration myself to Alaska during the spring and see the kind of onslaught of hundreds of thousands of birds arriving. So my research focuses on migration, and I have reasons for studying migration that are both sort of scientific in base, but also emotional. Not that those two are distinct, but I think why I study migration is because of the incredible diversity that migration allows us to witness. This is a graphic pulled from Audubon, has a kind of migratory explorer page in which you can explore all these different species that have been tracked over the many years of research and of these transmitters sort of being developed. And it strikes me every time looking at these maps and these track lines, how different organisms are. And this diversity exists between species, certainly, but also between individuals. Each one of these lines represents a different individual. Migration is really hard to witness. It's hard to observe directly. Usually we see it as an arrival or a departure of birds, or maybe a pulse of birds coming through at our feeders. It happens at night. It happens, tens of thousands of feet above our heads. It's really quite a mysterious phenomenon, uh, but it's one that helps us connect our landscapes, our airways. It connects the people that rely upon these places, the birds do, and it helps us understand the world around us and the changes it's experiencing. So I feel so lucky to get to study migration because I think it gives a glimpse into many fascinating and important kind of concepts in both science, but also in human connection. And in particular, shorebirds offer a really fantastic look into kind of extremes of migration. This clip is pulled from a PBS documentary called Flyways that I can share the link to. Um, Shorebirds are incredibly long distance migrants. They depend upon habitat hemispheres apart, habitat like mudflats and tundra, but also agricultural fields. They love coastlines, wetlands. Much of these habitats are somehow at risk, under threat from development, sea level rise, different types of climate change. And one thing that is so fascinating about shorebirds that you can see from some of this footage is that they do not ever glide. They don't glide, they don't soar on open air. They're constantly flapping. And so when we are able to track these birds and see how long their migrations are, we know certainly that these birds, unless there's a place that they can rest on land, they are flapping straight for at times hundreds and even thousands of miles. Shorebirds, uh, like the Hudsonian godwit pictured here on the left, um, often make journeys from the other side of a hemisphere. So the Hudsonian godwit spends its breeding season, its summer season up in Alaska and Southwest Alaska, and it winters down in basically the bottom of South America. And in between, it stops in really important area called the Prairie Pothole region there in kind of northern central North America. And it relies upon these tiny wetlands that are kind of disparate and spread out across an agricultural landscape. Hudsonian godwit give us an opportunity to understand how birds are adjusting to major climatic changes, how they're using landscape, and how their timing might be changing. Their migratory timing might be changing in response to these big climatic shifts. And because of their dependence upon so many different landscapes, almost all shorebird species are in pretty rapid decline. And this graph here is showing year along the x-axis back to 1980 when population estimates were pretty sound, and then their population trend here on the y-axis. So you can see that if we start at 0 here at 1980, both these lines and this gray one represents 29 species that have been tracked in rapid decline. And then this red line is 10 species that represent tipping point species, which means they've declined by more than 70% since 1980. So it's a myriad of issues. It's many issues that these species face that contribute to these sharp declines. They're incredible migrations, the fact that they are flying tens of thousands of miles is one of them, but also that all of these landscapes they're depending on are changing really rapidly and often not in the same way. There's heterogeneous change. This means that they are having to integrate and adapt and respond to many different types of change at both different parts of the world and in different times of their annual cycle. Um, so my research aims at helping alleviate and slow these sharp declines. If we can understand the differences between species patterns, where specifically these types of challenges, these types of threats might be occurring in their annual cycle, we can help slow and stop some of these declines and address some of the pressing issues. So the questions that guide my research are what shape diversity and migratory strategy. We know that many species use different routes, they use different timing, they make stops in different places, and I'm so curious about what shapes those differences and how they differ between population within a species, between species, and between flyways. And I'm going to explain a bit more about what flyways are in a bit, but generally you can think about them as migratory corridors. And this last question I won't talk about so much tonight, but it really helps guide my research, which is what are the different risks that these migrants are exposed to as a result of these differences in strategy? So to answer these questions, I am using transmitters, GPS transmitters, to track 6 species from 2 locations in their Alaska breeding range. These species are short and long-billed dowitchers, Pacific and American golden plovers, and lesser and greater yellowlegs. I've done 3 seasons now in Alaska, and I've gotten a chance to work with all 6 of these species. And tonight I'm going to tell stories from 3 of them, the short-billed dowitcher, the Pacific, and the American golden plovers. If I had 2 hours with you all, I would share more and more stories. But this is what I'll start with tonight. So these different locations I've mentioned, I'm aiming to track these species from 2 different sites each, and that's in an effort to understand how differences might exist within a single species. And because I hope many of you are Alaskans here on this call and you have a sense of where these places are, I'll share. Both the American and the Pacific golden plover I'm tracking from Nome, where they exist side by side and breed side by side on the tundra. But the American breed all the way up to Utqiagvik, and the Pacifics breed down in the southwest as well. The greater and lesser yellowlegs are mostly southwest and some interior populations, though last summer we did find a breeding pair in Nome. Generally, they're considered to be farther south and more interior. And finally, the short and long-billed dowitcher. The short-billed dowitcher are down here in the southwest, and the long-billed are up on the Seward Peninsula all the way up to Utqiagvik. So these are my field sites, and yeah, the place I've returned to, I guess just for 2 summers now, is in Nome to the tundra and the wetlands on the Seward Peninsula. So a bit more about migratory flyways. I think one of the things that really helps us understand why Alaska is such a special, unique place to study migration is because it is right in the center of many different flyways. And flyways essentially are migratory corridors in which migrants rely upon to move south and north every year. And these flyways exist across our continents. And tonight, I'm going to focus on kind of 3 of the flyways that define the Americas. That's the Pacific Flyway, and I didn't draw a line for it, but it also kind of extends out toward Pacific Islands here to the west. The Central Flyway, which goes down, and it kind of includes 2, the Mississippi Flyway as well, the middle of the country, the middle of the U.S. and down to South America, and the Atlantic Flyway, which includes kind of far north Canada down the Atlantic seaboard. And I guess why why do so many birds come to Alaska? Why is it such an incredible nexus of these migratory flyways? And the birds love it for many of the same reasons we do. The days are incredibly long in the spring and summer, and when raising their chicks, these birds have access to resources throughout the entire course of a 24-hour day. Um, there is enough resources, their chicks, who, when they hatch, they just start feeding themselves immediately. So, unlike songbirds like swallows and warblers, shorebird chicks hatch and, like chickens, can dry off and just start feeding themselves. And the tundra is so full of resources for these chicks to eat that they are able to survive. Um, the video is probably a little bit glitchy, but you all know these landscapes, I'm sure, and you all know how kind of important and special they are to so many organisms that rely upon them. And when I was first coming to Alaska, I definitely had sort of dreams of this type of scenery and this type of, wide open, long days. And my first field season, I didn't realize, first of all, how much easier it is to catch white socks than shorebirds. This is from king salmon. I did not realize how hard it is to walk on tundra, which I'm sure many of you have done, and it is like it's like walking on a carpet covered with bowling balls underneath, especially in the rain. And I didn't really realize how hard it would be to actually catch the shorebirds themselves. This is footage I'm hoping you all can hear um, of Hudsonian godwits sort of mocking us as we're walking through a wetland. We also got the chance when up there to explore the mud flats of the Cook Inlet, these enormous, incredibly resource-rich mud flats. We're out there collecting worms and trying to recite birds. Birds do not nest on the mud flats, and I would not recommend walking out on the mud flats. Um, but we did manage to catch a lesser yellowlegs in a dumping site for fridges. So Alaska offers incredible diversity of habitat for both the birds and for the people trying to catch the birds. So when we are in the field and we're in the right habitat and we are actually ready to start finding birds and catching them, one thing that we spend a huge amount of time doing is nest searching. And so I'm going to just invite you into the world of a shorebird biologist for a bit and have you first start with this image and try to find the nest. And I would love for people to engage on the chat feature on Zoom. So I'm curious, hopefully you can spot it, but what do you notice about these eggs? What do you notice about what are you seeing? What do you notice about the way these eggs interact with the landscape around them? And here's a picture of a Pacific golden plover. You can type in the chat things you notice. And I'll just reiterate, like when I was learning how to be a biologist or what biology was, observational skills and just saying what we notice and what it makes us think of, what it makes us, what it reminds us of is sort of one of the most foundational ones. Same color surroundings, says Doug. They look so much like the landscape, says Catherine. Yeah, these are excellent observations. They're so camouflaged. Yeah. These birds are great mimics. It's true. Their eggs are incredibly well camouflaged to match the lichen, the forbs, the grasses of the tundra around them. Okay, things are going to get a little bit trickier, so everyone get ready. I hope that was a confidence boost. You found the first nest. All right, here's the next one. The pattern of the four eggs matches the surrounding. Love it. All right, take a moment, see if you can find the nest in this image. This is of a different species. Doug says barely. All right, I'll give you like 10 more seconds to poke around. It's really deep in. So yeah, share some observations if you think you found it. I'm gonna circle it in just a couple seconds here. It's in the middle. Yeah, okay, nice work, everyone. So this is the nest of a short-billed dowitcher And go ahead, put in the chat what you notice, either about the nest there in the tundra or about the images of it on the left. The short-billed dowitcher have an incredibly different strategy. When the Pacific and the American golden plover, they hop off their nests when you're 100 meters away, but the short-billed dowitcher, they stay really, really tightly on their nest until you can practically reach down and touch the bird. So their eggs perhaps are not quite as well camouflaged, but the bird itself blends in incredibly well with the tundra. Anyone have observations to make about these chicks or these eggs? What do you notice? There is something sort of special about that egg on the bottom right of the nest image. Can't see the adult. Yeah, the adult is not actually sitting on that nest. Yeah, but the back of it really does camouflage well. Yeah, Lily points out the egg is pipped. And it's true, there's a little hole here in the egg. These chicks are just beginning to hatch. It takes about a day for them to fully emerge. Their pointy sides all face inward. Yeah, great observation. And looks like 4 eggs. That's very typical of shorebirds to lay 4 eggs. All right, we're gonna move on to the expert level. So everyone get ready. This is sort of cruel, but I think it's quite a fun game and it really helps illustrate how tricky things are. So take just a minute here, try to find the eggs. And if you think you know, you can put in the chat like a vague sort of, direction, maybe a quadrant of the screen, of the image. This one's really tough. I play this game, I visit middle schoolers, and they're actually quite, like, usually we wait for long enough and one of them finds it, and it's quite remarkable. Lichen crevice, no clue. Yeah, so maybe in there is the guess in the lichen crevice. Okay, take another moment here. Okay, here we go. Boom. That was tough. So that's a little blurry, but these are the eggs of an American golden plover. Quite similar to a Pacific, but generally they nest a little bit higher up on drier slopes out of the wet tundra. This is off the Teller Road. Some of you may recognize the scenery. They're really hard to find, and the birds hop off their nests and they just sort of walk away, and then you're left trying to find the nest. Even if you saw exactly where the bird got up, it can be super hard. This nest has 4 eggs in it. Okay, excellent. Thanks for entertaining that game, and know that that is a game that we're playing basically on repeat for about 2 months every summer. I want to show just a short clip of what an actual capture looks like. We use a net called a bow net. This is around an American golden plover up off Teller Road. You can see the bird kind of sitting back down on its nest here, and this is the net around it. There's a string attached to the net right here, and the biologist, me and another field tech, are lying maybe 30 feet away behind a tussock, waiting for this bird to sit back down. And once the bird is sitting and it's quite settled into its nest, then we pull on the string and it pops a little nail out of this kind of simple trap, and the bird is trapped. And then we scurry over and we pull the bird out of the net. And once we have the bird in our hand, we do a few things with it. We try to take as much information as we can before we release it again. We take some measurements, and then we attach a transmitter, a GPS transmitter, to the back of these birds. The GPS transmitter is attached with a leg loop harness. It's made out of a really stretchy material so that as the bird gains weight and loses weight, the harness sort of adjusts with the bird size. And these birds are quite small. They weigh about 100 grams, and the transmitter, to be safe for the bird, needs to weigh much less than that. So these transmitters weigh about They weigh about as much as a nickel. And they sit on the lower back of the bird. And because it's such a small transmitter, it has incredibly small battery. And these batteries allow us to take about 100 highly accurate locations from these birds. And my research, in part because we know very little about it, is focused on fall migration, on southbound migration, which is sort of a part of the annual cycle of migrants. We really have a lot to learn about. And so these transmitters are taking data points every 1 to 3 days or so during fall migration. So I'm going to share now some of the tracks of the first bird that I worked on when I first came to Alaska. And these are of the short-billed dowitcher. The short-billed dowitcher breeds down in the southwest in king salmon and in beluga. And we tracked them from 2 different sites to see if they use different routes to get to their wintering grounds. Of the 3 different flyways that these birds could have used, we were not surprised that they used the Pacific Flyway. These are the tracks from king salmon in the purple here and beluga in this teal. And we tracked these birds during fall migration. They all left Alaska in between early July to kind of mid-August. And they all made these pretty big jumps across the Gulf of Alaska. Um, and the Gulf of Alaska is a pretty formidable geographic barrier for migrants. There are very few islands within it for birds to rest upon. Middleton, right up here, is one of the only, and we did have one bird visit that island. Remember, these shorebirds cannot soar. They can flap. They have to flap. They cannot glide or soar, and they cannot sit on the water. So when we see these lines across the ocean, they represent nonstop flapping flight, which is pretty remarkable considering how small these birds are. And what we noticed in the tracking of these two different sites is that while they left, their departure date was about the same. There wasn't a difference between when they left Alaska. So this bar graph represents the X here is the date. So this is their departure date from Alaska, and these 2 boxes are king salmon in purple, these birds, and the beluga birds in teal, these ones. As soon as they left, the king salmon birds started sort of pulling ahead and winning the race down to their wintering grounds. So they crossed this line in Northern California here. The birds from king salmon, you can see, crossed that line much earlier in early July than these birds from beluga crossed it. And this pattern held down to Southern California. These birds arrived much earlier, those from king salmon. And finally, getting all the way down to their wintering sites, the birds from king salmon arrived much earlier. This was so exciting to see that even between these 2 sites that were relatively close together, we were seeing such a difference in timing. It was also really special for me. I grew up right in here in kind of central coast of California and the Bay Area. I'd seen these birds growing up, not knowing what they were and why this was such a special place, but to see birds that flew straight from king salmon, which was really my first field site, all the way to my kind of hometown and bay was really quite a special thing. And it made us so curious, this difference in timing, about what drove kind of access to what shaped this difference in timing. And one likely explanation is the wind in the Gulf of Alaska. So the Gulf of Alaska is kind of a confluence of 3 different currents and different wind systems. And as storms travel up the Pacific coast, they often kind of spiral out in the Gulf, and it means there are really different and sort of tumultuous wind conditions within it. And to understand and explain these differences in timing, we ended up looking at how tailwind differs between the routes from each one of these sites. And this figure shows that of the routes that birds took, which are these 5 kind of dotted lines, each one of these dots represents a location where we sampled wind conditions, and really red color indicates a tailwind for the birds traveling along this line. So a tailwind means a wind that is coming from behind and actually supporting and encouraging the direction that the bird is flying, versus a headwind would be a dark blue, and that is actually, a deterrent, or it's slowing, or it makes it more difficult to fly. I'm sure folks who live in windy areas know well about the difference between a tailwind and a headwind, and especially on my bike, I experience it the most dramatically. Um, so what we found was that the birds that were departing from King Salmon and making these enormous flights to either northern or southern California, oh, getting a note that we can't see all the graphic. Oh, I think the rest is coming. Um, the birds that were flying south were getting from King Salmon were getting far more access to tailwinds than the birds that were flying from Beluga. And that can help us understand a bit more than why these birds from Beluga were making shorter flights as they left. They were encountering more headwind and they just couldn't maintain a flight their entire journey. But it also could help us understand why the birds from King Salmon beat the birds from Beluga by almost 3 weeks. So these figures are showing how this is tailwind access here from King Salmon versus from Beluga across the sites that they actually chose, the routes that they actually chose, these lines. But then we also graphed, okay, what if these birds from King Salmon flew, straight up to Beluga, or they flew up to northern Washington? We found they still would get greater access to tailwind than the birds from Beluga. So across both the routes that they chose and the routes that they could have had access to, any direction they flew, these birds had a better wind deal. This is my first chapter published in Movement Ecology. It's an open access journal. If you're curious, I'd be happy to share the link and you can read more about it. Okay, the next story I'm going to share is from the American golden plover. This is a bird that you all had the most challenge finding the nest of, and they breed up on the tundra of the Seward Peninsula. That's kind of the southern edge of their breeding range. American golden plover, this is their kind of world range map. So in red we have their breeding range, in green is their spring migration, and in blue here is their wintering. And the yellow here is their their fall migration. So I'm going to pose it to you all, knowing that we have these three kind of flyway options that this species could choose. Which flyway do you think the American golden plover use as they leave from both Nome and Utqiagvik is where we tracked them from? Put it in the chat if you think that they used the Pacific flyway, the Central flyway, or the Atlantic flyway to get to their wintering sites way down in Argentina. Oh, Nate just shared the link to my chapter. Thank you, Nate. Central, says Doug. Who else we got? Central from Susan. Anyone else? Pacific from Elizabeth. That's an intuitive guess. Central Pacific. Anyone else want to share? No wrong answers. Well, there sort of is, but this is just the fun of it. When you make you got to posit some hypotheses sometimes, and often we're wrong, and that's sort of the delight of it too. Another Central. Okay. I'm going to reveal it. Everyone ready? Even if you're not an Atlantic. Oh, Karen! Okay, here we go. These tracks were so cool to see. We saw birds that, were initiating what we call southbound migration, their fall migration, moving north from Nome up to these islands in Canadian Arctic, and spending quite a bit of time foraging, stopping over at these tiny islands just north of Hudson Bay, and grouping up quite tightly during this kind of like late summer, early fall season. And then from there, all but one took these enormous flights down across the Atlantic Ocean. Very few of them stopped before they made this big long flight. And these points in here just represent, transmissions from from the GPS points. They don't represent stops. So these birds flew straight for the most part from up here north of Hudson Bay all the way to their wintering sites, or at least to South America where they first landed and touched down. This was so, so cool to see. And I want to zoom in and just highlight a particular part of this migration that really impressed us. That's a really good question, Susan. Why did they choose Atlantic? Let's talk about it in the Q&A section. I'm going to zoom in on this orange square and share another study that a lab mate of mine led, Jenny, and we contributed these tracks toward. So the Amazon basin is an incredible hub for migratory shorebirds, and not just American golden plovers, but 6 species at least that breed in Alaska end up stopping over in the Amazon basin on their journey, either south or north. These 6 species, many of them breed up, on the Seward Peninsula or nearby. And the American golden plover show a really, really tight kind of site, between them. This is just from a single year, a use of this northern kind of east part of the Amazon River. And I want to highlight that just between these, this is a bit tricky to see, but you can see this bar, this image from Google Earth is just 150 miles wide. And within it, we have 4 different individuals, 4 different American golden plovers that all flew from either Nome or Utqiagvik to use this patch of the Amazon River to forage along. So they came from thousands and thousands of miles away, and they all landed within a couple 100 miles of this stretch of river. It highlights just how incredibly important these sites are, the Amazon River in general, but also the mud flats around it and this particular area. As they moved farther south, they relied upon agricultural fields to get all the way down to Argentina and Uruguay, where they spent the winter. And this is what an image of their wintering ground looks like. And you might think, wow, it's not so different than way up here on Anvil Mountain in Nome, right? It's that kind of low tundra, and these birds are not in breeding plumage anymore. But you can see they have sort of, they've found a very similar kind of analogous habitat to that of Nome. Okay, the last story I'm going to share with you is one that is still sort of developing, and that is of the Pacific golden plover. We tracked the Pacific golden plover from Nome and from king salmon last year in 2024. And unfortunately, our transmitters did not do as well as we hoped. And this is pretty common in the tracking kind of world and research, is that due to could be a whole slew of reasons, but transmitters failing, transmitters falling off birds, birds dying before they begin migration. There are many reasons why we might not get like full successful tracks of an individual. But I'll share the tracks we did get, which show this striking difference in southbound migration between these 2 sites. So the birds from Nome ended up moving across the Bering Strait and down onto the, I always pronounce it wrong, onto the Russian peninsula here. And one of them, you'll note, did this enormous flight to Taiwan and south before it ended up wintering in Australia. The birds from king salmon, alternatively, ended up kind of staging on the Alaska Peninsula before flying down to the Hawaiian Islands, and 4 of them touched down on golf courses and neighborhoods, in backyards and graveyards. Thank you. Okay, Kamchatka Peninsula is where these birds ended up. So we see this incredible difference again within a single species between these 2 populations. This work contributes to the many years of tracking and research that folks in Hawaii and elsewhere have done on these species. The Pacific golden plover has been well studied by Wally Johnson and folks that contribute to the Kalea count in the University of Hawaii every year. So I got the chance to meet them on the tundra this year and share a bit about all of our stories about the Pacific golden plovers. So I'm going to zoom in here on this bird's incredible migration. And in particular, I want to start us first at Nunivak Island, where this bird touched down after it left Nome in September. So these images, these moving images I'm going to show are of wind conditions. So these are showing on a particular day of the year what the wind conditions were like. So this is on September 19th, 2024. You can see there's kind of a westerly wind blowing, meaning there's wind coming from the west, moving toward the east. And this bird has arrived to Nunivak Island, and it's sort of like sitting out, waiting for something. So this is 2 days before it did this enormous flight to Taiwan. And on the day of departure, quite dramatically, these winds changed. This is at sea level. Thank you, Rick. These wind conditions changed quite rapidly toward for an easterly wind blowing toward the west, and shortly thereafter, this bird took off from Nunivak Island, and it flew straight to here we go, straight to Taiwan. This bird flew straight from Nunivak Island to Taiwan, and let's see if this is going to work. In Taiwan, there we go. Hopefully this is working for you all. This bird ended up kind of bopping around at what I presume to be agricultural fields outside Luodong, a tiny kind of agricultural town. And this bird stayed here for a couple of weeks. And you can see there's like, what was it? Oh yeah, there's a driving range nearby, golf range. It's kind of like a neighborhood looking area. It spent a couple weeks there, and then it made another huge flight, stopping at a couple more islands along the way before it landed in the North Kennedy River to spend the remainder of its winter, and this is in Queensland, Australia. Here it ended up along this kind of big winding river, and folks that are used to flying over Alaska, you recognize these oxbow features of that generally are good indications of really wet, rich soil, and quite different, in fact, than the kind of pampas grasslands of Argentina, and yet different than spending the winter on in a neighborhood in Hawaii. So this is an example of both an incredible migration these Pacific golden plovers do, and also this diversity of landscapes that they rely upon throughout their annual cycle. All right, so in summary, these are some of my tracks I have of the 6 species I've been tracking for the last 3 years. My hope is to just impart some of the incredible diversity of shorebird migration and migration in general, what vastly different landscapes and places these birds rely upon, how many places that we can apply conservation efforts to maintain good habitat, be it keeping water on landscape and agricultural fields, or making sure that there are parts of the San Francisco Bay Area that are undisturbed for birds that are foraging in mudflats there. And really just how birds can unite people from so far apart in different parts of the world. And I feel kind of lucky to be part of that. And in my last couple years in Alaska, I've done a good amount of outreach and connecting with folks in some of the field sites I've worked. I'm not sure Kate is on the call, but I got the chance to co-write an article with her for the Nome Nugget, which should be coming out this week or next. So keep an eye out for that. And last year, I had a really fun time doing an interview with Desiree of the COTS radio station. She came out in the field with us as we caught a dowitcher and got some great audio recording. And last year, I also got a chance to have a community science night in Naknek that was hosted by Sheila Ring of the Martin Monson Regional Library. And connecting with the folks up in these field sites and sharing the stories of these birds has been such an important part of this research. So if you are someone in Alaska that would like to find ways to connect and brainstorm a collaboration, I am really open to that and would love to hear from you. I will be back in Alaska this coming summer and eager to meet you all and share more bird stories. So with that, thank you so much. All these folks listed have been incredibly helpful. And also thank you to these landscapes that host the birds and all of you wonderful people. Okay,
All right. Well,
questions.
thank you so much, Rozy. That was an awesome presentation. Are there any of your committee members or anything on here? Can you see that? Are there?
They should just pass me right now.
That's right. That's what I was going to say. That was magnificent. Give that PhD. Don't even, don't even hold it back. So anyway, well done. And now this is the time before we're going to think of the questions and all that. And I'm going to try to attach. I had a little hint that there was going to be an article in the Gnome Nugget, so we'll drop that in here. And it's already out this week, so it's out, and I'll send you a copy as well. This is the time in the chat box. It's never easy to be a straight science speaker or a public speaker, but you wouldn't know that. Rozy just wonderful job. And this is the time to show a little love to the speaker. For now, it's like 11. She's coming up on 11:20. Is that right? Yeah. 11:20. So wonderful. And with that, we'll start taking some questions. Doug, I see you right off the bat. Go for it.
Yeah, that was fantastic. Really enjoyed it. It was a wonderful, wonderful presentation. Thanks so much.
Oh,
Can
thanks for
you
tuning in.
comment a little bit about the transmitters that you use and just how they've developed over time? I can't imagine the work that you're doing would have been possible maybe 10 years ago.
Yeah, it's a really good question. And you're right that the technology is changing like practically faster than the birds are moving. So these are um, unique in that they are GPS level transmitters. They're 3.7 grams. They're called pinpoints. They're made by Low Tech, which is a company in Canada. And they are equipped to actually transmit data remotely. So we don't need to recapture the bird and retrieve the data off of the transmitter. And that is a huge breakthrough when before, and for many of these devices, still the smaller ones, it's necessary to recapture the birds, or rely upon a network of towers. Like Modus towers are an example that maybe some of you are familiar with, that sort of ping the locations as the bird moves near them. So these transmitters take data remotely. They take 3 locations, they turn on, and they send those locations to a satellite. And if there's a clear view of a satellite, that takes a really short amount of time, and that keeps the battery lasting for longer. But if there isn't a satellite nearby as it turns on, or if it doesn't have a clear access to the satellite, then it can drain the battery faster. So it really is a gamble about how long these batteries will last. And that is the tricky thing about having such a small transmitter, is that you end up with a really, really small battery. And there are many new and kind of like, it's amazing how quickly this technology is developing. So there are lots of solar powered ones now, ones that rely on cellular networks. And it's a super fast changing field. So you're right that just a few years ago we would be using different technology.
And they're a ballpark price. I've done it with salmon before. I know they're expensive and they're not nearly.
Yeah,
So they must be super expensive.
you are right. Yeah, they are about $1,700 each, one of these transmitters.
Ouch.
Yeah, yeah. And the data we get off of them is invaluable.
Agreed.
That's why it's extra disappointing when they don't work. Okay,
And,
I'm gonna go through the chat if that's okay, or if Gay, you wanna
yeah,
facilitate.
no, that's fine. I'll go through the chat. I just put in for you the Gnome Nugget newspaper, so everybody
Oh,
can read it.
wonderful. I
It's
haven't seen
on
it yet.
page 12. We had
Cool.
a large incident here, which is taking up a lot of the paper, understandably. So I think the first question you had was early on, why did they choose Atlantic? The pathway
Yeah,
for
that's
the
right. That's a good question. So that was one I'm really puzzling over. Susan asked it, I think. And it's what it says to me is it's a glimpse into the evolutionary history of these species, and that it doesn't really make intuitive sense that a bird breeding that far west in Alaska would actually make the journey all the way around, circumvent all of North America. And most of the species range is farther east, so it would make more sense that birds from the center of that range or the farthest east of that range. I'll go back to that slide so we can look at it together.
Yeah, the bug picture is like triggering me for summer ahead.
Yeah,
So
this is
I'm
not
just
a
saying.
part
Yeah.
of summer that we miss.
Yeah.
So this range you can see in red, the breeding range, goes all the way to this west coast of Hudson Bay. So all of these birds, it kind of makes more sense that they might use the Atlantic flyway. And a hypothesis I might pose is that as the range expanded farther west, which is an assumption that I'm making, we don't know if that's really what happened, but if indeed that did happen, that this range expanded farther west, then these birds might still have, because we know that migration has a genetic component to it, their orientation and their kind of bearing that they use does. So it's possible that these birds way out farther west here are still kind of going off of that bearing that they have, they've inherited. And it's possible that, maybe as time passes, as this option becomes less and less safe, or is too great of a risk, that this route starts changing. Who knows if that would happen or when that would happen, but it's a really good question that is pretty thought-provoking, especially considering that the Pacific golden plover, obviously they're quite closely related, is taking virtually an opposite direction.
There is a comment in the chat, and it was sent directly to me, and I don't think they meant to do that, but it's Kate. I'm on, Rozy. Wonderful presentation, and so great working with you on the Nugget article, the Gnome Nugget article.
Oh, I'm so glad you could tune in, Kate.
Yeah.
It was so wonderful working with you.
There's also a question on how did you get interested in birds?
Oh, yeah. When I was an undergrad student at UC Santa Cruz, I took a field course called Natural History Field Quarter. It completely changed my life and my direction, and the whole conceit of the course was just to be in nature and to learn from it, to make observations, and to learn more about ourselves and the landscapes around us through really careful, kind of considerate observation. And it wasn't actually all that scientifically kind of motivated, or scientific method motivated, but it slowly evolved into that for me. And birds, I think, are such a fantastic group of species because they offer so many questions, and they offer so many kind of different things to study. And even at UMass, I have friends who are studying physiology and disease, how birds, when they're migrating, alternate alter their immune system. I have lab mates studying how birds rely upon, a one tiny stopover site on the Atlantic seaboard. So I think that birds just offer this incredible diversity of questions you can ask, and then types of people that get interested in them. And they also are so accessible. I think that everyone, especially like when people hear that I study birds, everyone has a story about birds to tell, and I love that part of it. That it's actually usually a way to connect to people, and migration especially so. So it wasn't quite like the birds that were motivating to me when I first started getting into the natural world, so much as just the questions and the observations, and then birds became this incredible opportunity to do that. My first job with birds was on a seabird island where I was just inundated by, screaming gulls and getting pooped on and attacked, and it could have weeded me out, as I think it does to some, but I was like, this is it. This is the best stuff. So yeah, it's been birds since then.
Awesome. There was a question, at what point in the year, from Rebecca Taylor, at what point in the year do the offspring disperse from their parents?
Oh, that's a good question. Yeah, so shorebirds are quite unique in that, as I mentioned in that video, you can see a red knot on the tundra here. I'll just pull it up again as I'm talking. This is a chick that's it's less than a week old and when that clip was taken. So these birds, these chicks are foraging alongside their parents for the first couple weeks of their lives, and they start being able to thermoregulate with about like 5 days old. So for those first few days, they're really reliant upon their parents just for warmth, not for food. They're feeding themselves immediately, and they're swimming on ponds, and they're running around and slowly growing their flight feathers, and able to take short flights. So it is actually pretty early in their life that they separate from their parents, and usually the females, shorebirds, leave sooner than the males do. Um, they kind of co-parent for the first week or so of the chicks' lives, and then the females will leave. The males will stay around for another couple of weeks until chicks can fly, and then they don't migrate together. The parents don't necessarily migrate with their young, which is kind of one of the most incredible parts of shorebird migration. And one of my collaborators and just dear mentors, Dan, tracked a bar-tailed godwit, B6. He did a straight science talk a few months ago, I think it was maybe a year ago now, about this incredible first migration of bar-tailed godwits nesting on the Seward Peninsula. This chick that hatched it, they got it, they were able to recapture it when it was old enough to actually hold one of these adult transmitters, and they tracked it all the way to Tasmania. So that was an incredible case of this huge flight that this bird conducted just within the first couple months of its life. And it didn't do it, so far as we know, with its parents. It might have done it with other birds and other adults potentially, but the chicks are separated from their parents quite young, and they conduct these first migrations without them. How they know where to go and when to leave, and which kind of route to take to get to their destination is full of a lot of mystery. There's a lot of ways we can like posit answers about that, but a lot of it is sort of mysterious. Oh, Gay just put Dan's straight science talk in the chat.
Yeah, it was also bird people, just really fantastic speakers, all of you. It's amazing. Okay, next question. It says Catherine, but then it says this is Amy. Do you do you think the bird that flew all the way to Australia will age faster than its peers?
Huh, that's a good question. Yeah, so does this huge distance sort of might it impact maybe the fitness of this bird? Yeah, so it's in part a good question because we don't actually know where a lot of these birds on the Kamchatka ended up spending the winter. A lot of these transmitters stopped transmitting, and we're not necessarily certain that they ended up spending the winter there. So these birds could have continued their flight to Japan or to some other Pacific island without, and done an equally enormous flight. But I guess, yeah, the real like core of the question where it might be like, does a longer flight mean a shorter or like a greater distance flown? Might that somehow kind of have a weathering effect on a bird and cause them to live a shorter life? Which is, I think, a really good question. And yeah, there are some shorebirds, I mean, the short-billed dowitcher are an example where they don't actually migrate that far in the grand scheme of shorebirds versus a Hudsonian godwit that goes all the way to the southern tip of South America. So far as we know, like, well, I guess that's between species, so it's a bit different than the question you're asking. But I think it is an interesting one, and I think that longer distance migrants, you could argue, have more kind of exposure to threats because they're traveling across more landscapes, and potentially exposed to just more challenging conditions. But the truth is also that all of these routes, all of these landscapes are changing really rapidly, and so it's hard to say what is a safe bet kind of these days. What's a safer strategy? I think about it a lot with the short-billed dowitchers. Like, is it safer to fly this kind of direct route across the Gulf of Alaska, not be able to stop this entire time? Or is it safer to follow the coast? And you might think, well, certainly it's safer to follow the coast, but then that might require more stops. And each one of these stops, you face a lot of, it's quite energetically demanding to stop and take back off. And what if there isn't a good food resource there? Or what if you're exposed to some predator or to a parasitoid or something there that might, incur greater damage than just like this potentially tailwind fueled direct flight. So it's a good question because there are lots of ways to try to answer like what exposes birds to more risk, and I think that is a lot of what my research is probing at. So thank you, Amy.
All right, thanks. I'm just curious, at what's the altitude that these migrations for your short-billed dowager, what elevation are they kind of steaming
Yeah.
along?
So the highest one we recorded at and so some of the transmitters did have altitude recorders. The highest ones we recorded was at 4,700 meters. Yeah, 4,700.
Okay, all right, yeah, all right, that's interesting. Very interesting, and I know, I'm just telling the audience, it's like 11:30 where she is, and if you're okay with still answering some questions, you're
I could
doing
do, yeah, I
awesome.
could do one more.
Okay, okay, well, let's look in here, let's see, are you surprised that wind direction may be emerging as a driver for when and where the birds migrate? And if so, how does this inform conservation?
Yeah, okay. The wind has really captured me because I think it is oh, I think it's such a variable thing. And the trend that we're seeing that a lot of folks are writing about is this trend toward global stilling, and that a lot of our really kind of reliable, consistent um, wind patterns are starting to slow and become much more variable than they were before. I mean, since early records began, and wind is one of those tricky ones where we don't actually have like excellent records in the way we do of temperature to really track climatic change in the wind sphere. But I think that it makes a lot of sense to me that wind conditions, and this has been shown across many different taxa, many different species of birds, that wind can help trigger departure. Or guide a bird on which direction to go. So the fact that they're using wind as either a cue to leave or they are using it as a tailwind does not surprise me. But I do think, especially for a bird like that Pacific golden plover, when it left Nunivak Island, it had really nice wind conditions, but those are not the conditions. We're talking about an enormous expanse of the Pacific Basin. So the wind conditions that were here in Nunivak were not necessarily consistently tailwinds all the way across to Taiwan. And I think that is a question that I'm really interested in, is how kind of how reliable the conditions are at departure in terms of reflecting the conditions in flight. And are there any misleading cues? Or are there cues that are potentially getting more mismatched as these wind conditions change globally because of climatic change? So I think that it's hard to imagine like how it would inform conservation, because we're talking about you know wind conditions, like, right? How do you make applicable conservation kind of actions for that type of change? But I do think that then identifying where the really critical places are where birds are landing after especially like a really long or really taxing flight, identifying those sites that they are flying to and touching down on, and that's a huge part of this northern coast of South America. For the American golden plovers, they're doing these huge flights and they're touching down and they're arriving just so haggard and needing to recover really rapidly, super vulnerable time. So identifying those sites and really protecting habitat that those birds rely upon, to me, is the kind of, at least one of the options for conservation action when we think about like how a transoceanic flight might be facilitated or hindered by the wind conditions that the birds face along the way. Yeah, but it's one that I am likely going to write another chapter about, is the wind conditions in the Gulf of Alaska, and during that first flight in particular, it's really quite remarkable.
So, Rozy, you've done such a good job that there are actually 3 or 4 questions left. Now, I don't know if you want to continue on, or if you, because you're approaching midnight, and you should take. I hope if anybody is with Rozy's school work, give her tomorrow off, or let her come in at noon or something. Honestly, honestly, we're really appreciative of the big time difference you're operating under.
Yeah, okay, I could do one more.
Oh, I don't know how to pick it. We'll just, I guess, go and, but here, I'll give you the questions. How about that?
Okay.
I'll read them out to you and you pick it. All right. The first one is, did the Pacific golden plover overwinter in Kamchatka? Would the temperature there be too cold? That was one. Isn't the route something close to the Great Circle route to southern Brazil? That's the second question. There's a yay UCSC.
Oh, good.
Did you observe any unique migration movement from any birds, like reverse migration, tornado avoidance? And Kate Persons has, is it known if the Hawaii wintering population is doing better than those breeding here and making a much longer migration? Now, I can read those again. You can pick whatever you want, or you can chunk them out however you see fit. We don't want you to keel over in exhaustion, and we really are appreciative of the big time difference.
Kate said, "Forget mine, we'll talk later," which I love. Okay.
Okay, that's good.
Yeah, the Great Circle Route one is interesting to me because I was just working on another paper about what a direct route would be from some of these sites. So the question that Rick asked is, isn't the route something close to a Great Circle route to southern Brazil? So Great Circle routes are a way to project the most sort of direct line between two places on the globe. And I just worked on some of this analysis because I was not looking at this species, but a different one, the lesser yellowlegs, which I can just sort of pull up this tiny map for at least. So this is the lesser yellowlegs, this map here, and these birds are breeding really all over Alaska and then traveling through this area called the prairie pothole region to get to their wintering sites. And I was curious, okay, is the prairie pothole region actually en route if you were to map the Great Circle distance? Like, are they taking a huge detour out of their way to use it, or are they following kind of like the most direct route and it just happens that this is on way? So it is different because Nome is slightly higher north, but the Great Circle route from a lot of these sites in Southwest Alaska is not around, it's not through the Central Flyway, nor is it through the Atlantic Flyway. It's actually like much closer to this kind of cutting edge of the Pacific Flyway. So the birds from the American golden plovers that are taking this long way route are not necessarily following a really direct route. There's quite a bit of detour happening there. And I guess what that also points to is just the importance of kind of resources and abundance that this area must hold, considering what high connectivity we see there. So many individuals kind of focusing and honing in on these spots. And the fact that they're doing it from these different sites, right? It's not just like the one population traveling together to get there. They are all really, it's like a magnet zone, and that's what we're kind of seeing with these lesser yellowlegs too, is that they're departing from all over the place and they're all showing up in this one area in the middle of the country. So yeah, Great Circle route is an interesting way to test kind of how much of a detour a bird might be taking to get from A to B.
All right. Well, thank you. And I think actually Rick has jumped off, but he did. Now this may, Rozy, you work up here and all over, and I see that there's people on from Nome, and there's also others who also are interested. He just gave us the first, we're having very unusual conditions right now. We have had very warm weather. So yesterday it was almost 40 degrees Fahrenheit. And our shore fast ice let go. And I'm just going to hit the go button here so you guys can see this is from today.
Should I stop sharing?
Go. No, no, I'll just put it in the chat and everybody can
Oh.
take a look at it.
Oh,
And so it is, the ice has retreated in the last week or so, very far north. And we are coming apart, like, so for our Nome, right? That's very shallow, as you know how you look out south and you see the sandy beaches of Nome, right? When you're up here. So that's quite unusual to be not even in mid-February. It shouldn't be breaking at all. And like I said, we have eiders now that are being seen. So I don't know what that means for this, what lies ahead, but it looks like we are way in advance for ice retreat, and we won't really, we're going to get cold again here. I think it's going down to -10 Fahrenheit, but we won't have much time left. We're almost, it's going to be March here in a little bit, and then things take off here. So I just wanted to sort of give the heads up for that. If people find that of interest. That's Byrick Toman who asked that great circle route. So I wrote down your answer, so he will get that.
oh,
And
good.
he
Okay.
gave this picture of where we are today. And it's a stunner. If you work in the marine environment up here, means a whole lot of things are probably going to happen really quickly this spring.
Okay, that's good to know.
Yeah, I don't know how would that affect your shorebirds, something if we get an advanced
Yeah,
open water season.
certainly. Yeah, if spring is arriving earlier, I mean, it's one of the most
It's
like
February.
questions we have about, the mismatch in timing between migrants and peak resources.
There you go.
Yeah, so it's interesting. Yeah, how much could birds advance their arrival?
Yeah. So you're getting lots, and Kate got it right on there. I hope you can see her comment. Best straight science ever.
Yeah.
I'd have to say you were excellent speaker, and we'd love to get you back. So get back. Are you coming back this summer?
Yeah, that's a little
right.
up in the air still, but I hope so.
All right.
Yeah.
Wonderful.
Okay, thank you so much, Gay, and thank you everyone for joining.
Go to bed.
Yeah, I'm on it.
All right. All right. We'll talk to you later. Thank you so much.
Bye.
Bye-bye. All right. And for everyone else that's on, the next Straight Science will be on Wednesday, this coming Wednesday, the 19th. We've got Sarah Hensley. She is our area wildlife biologist, and she will be giving us a status and the current status of 22 Game Management Unit 22C and 22D moose for the Nome area, the Seward Peninsula area. And she's going to give us sort of a review of what's been done by the Alaska Department of Fish and Game from 2018 to now, and where they think moose are headed for 22C and 22D. So we'll see you next Wednesday. It's going to be on a Wednesday, February 19th at 6:30 Alaska time. Thanks everybody for coming, and have a great night. We'll see you next time. Bye-bye.